Hey, and welcome to the implicit and explicit wait section. I'm so excited to be here teaching you about these very important topics. Implicit and explicit waits are critical in Selenium WebDriver, and they're going to help you to understand how to write code that is not flaky, how to reduce flakiness in your GUI automated tests. So first, I'm going to introduce you and show you why synchronization is actually important. How synchronization actually leads to flaky tests, so then you can learn exactly how to avoid those flaky tests. Next, you're going to learn about implicit wait. You're going to learn exactly what it is, how to create an implicit wait using Selenium WebDriver API, the default timeout, and the exceptions that are thrown when you use an implicit wait. Next, of course, I'm going to teach you about an explicit wait. A lot of times those two are thought of as counterparts, implicit waits and explicit waits, and many individuals are always confused about the difference between the two. And so that's why I'm creating this tutorial, is to help differentiate and help you to understand what an implicit wait is and what an explicit wait is, and what is the difference, how to use each one, the type of exceptions that are thrown, the default timeouts, and all that kind of stuff. So at the end, you're going to be crystal clear on exactly what an explicit wait and implicit waits are. And finally, I'm going to tell you some huge changes that are coming in Selenium WebDriver API. Literally, less than 2 weeks ago, Selenium community announced that they're going to be making some huge changes that are going to drastically affect how we write test automation code, and in relation to actually all of the implicit and explicit waits, and is going to cause havoc in your code if you're not prepared. So I'm going to tell you about those changes. I'm going to tell you how to prepare for them. And then whenever they come, you're going to be ready and you're not going to have any problems. So let's go ahead and jump right into the content. If you're enjoying this tutorial and want to support this channel, be sure to hit the thumbs up button for the video. And if you want to be notified of every time a new tutorial is released, hit the subscribe button. Now, before we jump in, let me just quickly mention the resources for this section. Remember that there's always this page, the resources for complete Selenium WebDriver course, that you should always be referencing. You should save it. You should bookmark it. And if you come down to the topic, implicit and explicit waits, you'll have all of the information that you need that we use in this section. You'll have the code, you'll have the URLs and all that kind of stuff. And then there's also a very important blog post that I wrote. If you actually hit this shortened URL, it's case sensitive. If you hit this URL, what's going to happen is it'll take you to this page, and this page clearly and concisely defines the differences between an implicit and an explicit wait. So if you forget, or for whatever reason you're not taking good enough notes, you can always just come back here in the future, gauge on this post to make sure that you fully understand the differences between the two. Now let's go ahead and talk about implicit waits. Here in the solution explorer, what I've done is created a class called implicit waits, and this class will help us to learn everything about, well, implicit waits. So as you can see here, I've got a test that's set up. We're going to go ahead and debug this test just so you can see exactly what it does. I'm going to come here and I'm actually going to right click and I'm going to say debug tests. And so while that pulls up, you can see that up here I've got a test initialize attribute. In the test initialize attribute, we use a WebDriver factory, which is just a class that I created that allows us to create a Chrome driver, and we store that inside of the driver variable that's accessible to the entire class. And then in the test cleanup attribute, which will run after every single test, we obviously close and quit the driver. So that's not so relevant. I just wanted you to know that it's there for your information. And now what I'm going to do actually is I'm going to take this window and put it through the test. And as we step through the test, you'll be able to see the actions happening in the window on the left. So now we're going to step over this action, and we're going to go to a URL which lives in a class, static class that I created called slow animation URL, and it goes to that URL right there. So I'm going to go ahead and step over. You'll be able to see that happening in the browser. And then once it goes to the URL, next thing we're going to do is use this method that's called fill out credit card info. Let's see what that does. Might be a little bit self-explanatory, which is kind of great, but let's go ahead and take a look. I'm going to go ahead and step over that. So now I'm stepping over that method. Did you see exactly what it did? It filled out all of this information. Then we're going to click this go button. Step over that. And so now, as you see, we filled out all of this information. We got the credit card information. We got the month in here. We got the year. And then this last action that we just did, which was find element by ID go, what it did was click the purchase button. And then once we click the purchase button, you see that this purchase complete text appeared. And so now we're going to have an assertion, and this assertion checks to see if there's this element with ID success and if that element is displayed. So let me step over that. Looks like it passed, and then I'm actually just going to go ahead and say continue here. So the test finishes running. The browser was closed thanks to the teardown method, and now we have a green check mark. So the test was successful. You saw exactly what the test did. And we stepped through it, so you saw all the code, and now you understand exactly what's happening. The fill out credit card info is right here. So now let's go ahead and rerun this test so that you can see it executing in real time. So now the test is going to go ahead and execute in real time. I'm just running it. There's not going to be any kind of debugging because you already know exactly what the test is supposed to do. So we're just basically running it, and then we're going to see how it works in real time. So there it is, filling everything out, and then it finished, and it failed. Wow. And here's the error message saying that this test threw an exception. OpenQA Selenium element not visible exception. Element not visible. Very weird, right? How the heck did the test just fail if we just saw it pass? That is an interesting dilemma. Think about it. How is that possible that our test just failed, even though we just saw it pass? When you come back, I'm going to explain to you exactly why that happened. So, did you think about why the test failed the second time? Hopefully you were able to figure it out. If not, no big deal. I'm going to tell you and explain to you exactly why that failed. And the reason that it failed is a very standard, very common synchronization issue when you're doing UI functional test automation. What happens with functional test automation is that your code is too fast for the browser. The browser operates in seconds while your code operates in milliseconds. So the commands that are executed using the code are way too fast for the browser. And so that's exactly what happened here. So you can watch if I step over this line that's going to click the purchase button, and I'm going to go ahead and step over right here. What's going to happen is you're going to see this loading icon come up. However, on the right-hand side, you can see that my Visual Studio is already at line number 35. And so it's ready to execute the next statement, which is an assertion to double check that the success element is displayed. And you can see it actually even tells me the time that it took, which was 1,258 milliseconds, while you saw that the spinning icon was happening for multiple seconds. And so that is the inherent problem of all UI test automation as it stands right now, is the synchronization problems. So this would have executed before this even finished loading on the left-hand side of the application. And so the purchase complete message would not have been there, and so the test fails when it executes in real-time production environment. The reason that it didn't fail when we were debugging is because we took some time to step through it, right? I clicked this and then I was talking to you and this finished loading. And so then by the time I went to finish the assert, everything was completed successfully, as it will do so now. So look, if I do the assert, everything works successfully. But when you run it in real time, that is when the problem occurs, is when those synchronization issues happen. It's extremely common with Selenium WebDriver and all UI test automation frameworks. That's why you need to have synchronization points, and that's why I'm here to teach you implicit and explicit waits, which I'm going to cover over next. So Selenium provides us several ways to deal with synchronization problems. One of those ways, as you may have heard in the industry or you may not, it's called an implicit wait. Well, it's actually called an implicit wait, but implicit wait means, different options. So what is an implicit wait? Well, an implicit wait basically tells Selenium WebDriver to poll the document object model for a certain amount of time when trying to find an element or elements if they are not immediately available. So it's basically checking the DOM to see if that element is present. If it's not present, it's going to keep checking for a specific duration of time. So how do you use an implicit wait? Well, an implicit wait is pretty easy to use. You do driver.manage.timeouts.implicitWait. It's a property, and then you set it to some time span object, and then you set from seconds, from minute, from days, and so on and so forth. I hope you're not setting implicit waits from days, but it should normally it's from seconds or from milliseconds, depending on your implementation. And of course, I'll show you that in code. What is the default timeout? So if you do not set your implicit wait, right, as you can see in the usage, I've set it, but if you don't set it, the default timeout is actually 0 seconds. So what that tells WebDriver is if you're looking for an element using driver.findElement and it doesn't find that element, it's going to fail immediately, which is exactly what you saw in our initial test, where it was looking for that final element to check, and that element wasn't present in the DOM, and so the test failed. What are the disadvantages of an implicit wait? The disadvantages of an implicit wait are that it's useless if the element is hidden on a page. So what does that mean? It means that if the element is there, but it's simply just hidden, the implicit wait will not work. In fact, it will fail immediately. I'll show you that after. The other problem with implicit waits, although it's less of a problem, than the first one is a huge major problem that's going to cause insane flakiness in your tests. But the second one, it's still also a problem, but it's that the implicit wait applies to all future commands utilized in your test. So if you set implicit wait once, it will now apply from this point forward to all of your tests that are running, obviously executing within that driver, right? While the driver is existing in memory, it will all be applied to that, all those future commands. So whether you want your driver to wait for a long time or you don't, it's always going to wait for that set amount of time. So when should you actually use an implicit wait? The answer is actually never. Yes, I know you must be annoyed right now because I've just spent all this time teaching you about an implicit wait, and then I'm telling you never to use it. How can that be? Why did I do that? Well, the reason I did that is so you know about implicit waits, you know what they are, and then you know that you should never use them. In fact, there is no reason that I've ever encountered why you would need an implicit wait. In fact, after everything I show you, you're going to realize that implicit wait is not only useless, but because you can't combine it with an explicit wait, and you shouldn't, as recommended by Selenium WebDriver, you shouldn't mix implicit and other waits, then it becomes the fact that you should never use implicit waits. Let me convey to you that through course, code, and examples. So just to prove some of my points, what I've done here is I've created the same test, and it's called test1 fixed implicitly. As you can see, it does exactly what it previously did. However, what it now does is it sets an implicit wait. You can see here's the usage that I've talked about, and I've set the implicit wait to wait for 5 seconds. So we're going to fill out the credit card info, and then we're going to find the element, and then we're going to perform all the same actions as before. But what this means for Selenium WebDriver now is anytime it uses the find element method, it's going to wait for up to 5 seconds before it throws an element not visible exception. And so it's going to wait for 5 seconds, and then if it doesn't work, it's going to throw up an exception. Otherwise, it will continue. It will continue to poll to see if that element is in the DOM before failing. So let's go ahead and step through this test. Actually, let's just go ahead and run it and see whether this test succeeds. So I'm going to come here and just click Run Test. And so now the Test Explorer is just going to go ahead and build. It's going to build a couple tests, and then it's going to start test execution. We can look at the Test Explorer, and we can see this green bar that keeps moving, which means that the test is in execution mode. You can see the browser has opened up here. It's going to navigate to our URL, fill out the appropriate information, and then it looks exactly like before. The test failed again. When we look at the error, we see the same exact error saying element not visible. And then, which is very weird, right? Why is the element not visible? I just don't understand. Well, it's exactly as I showed you. It's the fact that implicit wait is totally useless when the element is hidden on a page. Let me show you. Look, I'm going to go to this slow animations URL. I'm going to copy it. I'm going to open up a brand new browser here. And then we'll take a look at this element that I'm waiting for. So we're waiting for this element called ID success, okay? And we're supposed to wait for it for 5 seconds. So if I got Chrome up, and then I look for that element, I got Chrome tools up. Let me hide this over here. And then remember, we can use the Command F feature, Control F if you're on Windows, and we can search by ID. So I can actually just search. Sorry, I forgot the ID that I was looking for. Success, not go. Success. So if I search for the string success, you can see that there are 3 elements that I find, and we can search through them. So here's 1, there's 2, and then there's 3. Okay? So here's the one that we want. You can see that this is a div that contains a ID called success. And although it is not visible on the page, you can see that it's in the HTML. In fact, its display is none, which means it's hidden. But it's here in the HTML, but it's not present on the page. So what that means is it's hidden, which means that no matter what, the implicit wait will never work. And what that means is that you can't resolve this problem using an implicit wait. This situation right here, you'll never be able to solve it using an implicit wait. So the question that you probably have is, when will the implicit wait actually work? Well, let's cover that example. Here's another test that I wrote, test 2. The reason I'm calling this test 2 is because it's going to a totally different URL. So not using the same URL as before, which is ultimateqa.com, you know, the best website in the world. No, I'm joking, of course, but it's going to go to ultimateqa.com. It's going to set an implicit wait of 5 seconds, and then it's going to try to look for an element with ID success. So let me actually show you ultimateqa.com here, and as you can see, here's ultimateqa.com. I've pulled up the URL, the web page, and I searched for the string success, and it's nowhere to be found. Okay, it's nowhere in the HTML. There's nothing that is success, which means that there's no ID success. Okay, so now with that said, let's go ahead and run this test and pay attention to how long this test takes to execute. So we're going to start running this test. But just remember how fast the tests above failed whenever an element wasn't found. Check this one out. So it's pulled up the web page, and now the test is not finishing. What did it do? It actually was waiting for 5 seconds to find that element. So if we actually come here and look at this failure, you can see it was a 13-second runtime for this entire test. So that's because it was waiting for the 5 seconds before getting to the step. You don't believe me? I can throw a breakpoint here. I can debug this. Let me pull it up over here, and then I'm going to step over this and watch how long it takes to get from this step to this step. Step over. Oh, and sorry, from this step to this step, because this step just says the implicit wait. It doesn't do anything. This is the one that actually does something. So watch how long it takes to go from here to this curly brace. See how it's stuck and not doing anything? And boom, an exception was thrown. No such element exception. No such element, unable to locate element, which is exactly what happens when the element was not found. Does that make sense to you? Because the element is not in the HTML, that's when the implicit wait works. And so that is when it's actually useful. However, remember that if you set an implicit wait, in the future, when I teach you about other waits, you cannot mix them. I'll show you that in the future, don't worry. But you cannot mix implicit waits and other waits, which is one of them is explicit waits. It's not recommended by the Selenium community. So that's what it means, is that you just shouldn't use an implicit wait at all, ever. So with all of that, I think you're now ready to dominate implicit waits. And so, of course, I have a quiz for you, a fun little exercise that I've created for you to cement all of your knowledge. Let's talk about this exercise very quickly. So one thing I want to clarify again is that there are basically two types of exceptions that are thrown. There's an exception thrown that is called element not visible exception. And guess when that exception is thrown by Selenium? Well, when an element is not visible in the HTML, meaning that the element is there in the HTML, but it's just hidden. So in that case, an exception of type element not visible is thrown. And then we have a second type of exception that is thrown by Selenium, and that is no such element exception. That's exactly what you just saw at ultimateqa.com. And when do you think that exception is thrown? Well, it's thrown when there is no such element on the page. So in the Ultimate QA's case, we were looking for an element by ID success. There was no such element present. Hence, no such element exception was thrown. Okay? And so what I've done here for the exercise for you is I have the tests. I have 1, 2, 3, 4, 5 tests. Okay? 2 of which are new. One test here goes to this URL called hidden element URL. We can take a look at it here. Hidden element URL. Okay, so in here, there is an element present, but we can actually open it up so that you can see. And then there's an element present, and then it sets an implicit wait and clicks, which is this method right here. So it just sets an implicit wait and checks for an element with ID finish. Okay, let me pull up the browser. Go to this URL. And now inspect this area here. And so then we're looking for finish, right? So finish, look, we have two elements. Well, we're not looking for this JavaScript function. What we're looking for is for this element with ID finish. Okay, and it's there. Okay, so that's why I said it's a hidden element URL, and the other one is the element rendered after URL. So it means that the element is rendered after you click the button. Let me show you this one. So we're looking for finish. Just be careful. Make sure you retype your query. Retype your query after you reload, because you saw in the beginning it didn't find anything, but then after I retyped it did find the JavaScript function. But the JavaScript function is meaningless because we're looking for an element with ID, and there is no element with ID finish. So it's rendered after you perform a certain action, so it's not on the page. So explain those tests to you. So those are the two tests. And what I've done for each of these tests is I've placed this attribute called ExpectedException. So I'm expecting that each of these tests will throw a specific type of an exception. So this one will be a no element not visible exception, and this one will be an element not visible exception, then this one will be a no such element exception, and so on and so forth for all of the tests, with the goal of making each of the tests pass, because I know the exact conditions of each element, and I know whether an implicit wait will work or will not. So the problem that I have for you is the expected exceptions that I've placed on each of these test methods. Are they correct? So for example, if I run all of these tests, will all of them pass? Will this test right here, test 1, throw a element not visible exception, or will it throw a no such element exception? Will this test right here throw a no such element exception, or an element not visible exception, or even something else that I didn't show you yet? That is what you have to figure out. You need to go ahead and think about it. Think about the state of the elements that we're looking for. Think about whether an implicit wait will work or will not, and then figure that out. When you come back, I'll give you the answer. Okay, fantastic. So hopefully you were able to figure that out, because that was actually a pretty easy exercise. And the way we can see whether all of the exceptions were valid or not is, you can see that I have a test category here called implicit waits. So all I have to do is go into my test explorer and make sure that I'm filtering by categories, traits, which I am. And then all I have to do is find implicit waits down here. And as you can see, I've got 5 tests under implicit waits. All I have to do is right click, say run selected tests, and if my expected exceptions were correct, all of the tests should pass. Now, we're going to watch all of them run and see if all of them pass. Now, if you were not able to get this, it's actually very straightforward and very simple, as I said. If the element exists in the HTML when you try to check for it, but it's hidden, you're going to get a element not visible exception. When the element does not exist in the HTML when you try to look for it, then you're going to get a no such element exception, and the implicit wait will work. That's it. There's only 2 conditions that are possible for the implicit waits. So that's how you resolve all of the problems. Here we go. You can see that the test output, run test finish, 5 ran. We can go into the test explorer and we see this green bar. It means everything has passed. We can even expand this and we can see that all of our tests have ran. So all the exceptions that I had, the expected exceptions that I had there previously, they're all valid. So, and I explained to you exactly why that is the case. If you're not understanding why that is the case, go open up the HTML and see the presence of those elements and see if they match one of those 2 conditions that I mentioned to you. So you must be a little bit frustrated now, because I've spent all this time teaching you about these implicit waits that are supposed to resolve your synchronization problems and reduce your test flakiness, but I actually told you never to use them. So what exactly is the answer, right? You must be asking, how do I resolve these flakiness problems and synchronization issues in my tests? Well, that is actually what is known as an explicit wait in Selenium WebDriver. That's exactly what I'm going to teach you over the next several videos. And I'm also going to reveal to you some huge news that affects everybody with Selenium. It's something that literally happened 2 weeks ago, and I'm recording new videos. Barely anybody even knows about this. Only a few of the close Selenium committers and those that closely follow Selenium know about this. And there's a huge issue that's going to be caused for all of us. Everybody is going to be affected. So stay tuned, because I'm going to show you expected conditions. I'm going to teach you explicit waits, and I'm also going to reveal to you a huge problem that is coming up with Selenium. So let's talk a little bit about explicit waits. What is an explicit wait? Well, an explicit wait is the code that actually you write to wait for a certain condition to occur before proceeding. If you noticed, with the implicit wait, we actually didn't write any code to wait for any conditions. What we did was we set an implicit wait property to a specific time span. However, we didn't write any code to be waiting for any kind of conditions, right? We didn't wait for an element to be hidden. We didn't wait for an element to be visible or displayed, or for text to be contained inside of an element, or any kind of that stuff. An implicit wait is already set by Selenium, and it's also set in the browser. Each browser has their own implicit wait implementation, and so we just set it. However, with an explicit wait, you write the code and tell Selenium WebDriver to wait for a specific condition. Don't worry, you'll see with code examples. So usage, I will show you that in the code. It's not going to fit in this tiny little slide box. I'll show you that in the code, as that will be the best place to see all of this. The default timeout for an explicit wait is ½ a second. What does that mean? It means that if you don't specify the time for an explicit wait to wait for a specific condition, ½ a second will be the amount of time that it waits before it throws an exception. The disadvantages of an explicit wait are that, well, it's actually only one, is that it should be used for all slow loading elements, which means that you might have a couple lines of code anytime you need to do a synchronization point, right? So whenever you're switching between different kinds of pages and you want to have a synchronization point, you need a couple lines of code that utilize an explicit wait. It's not a big deal, because that is kind of required for you to avoid flakiness. However, it can, obviously add a few lines of code to your code base. So when should you use explicit waits? You should use them for all slow loading elements that need a synchronization point. So like I said, anytime you're switching between pages and there's a slow loading element, synchronize on that element for that page prior to proceeding with any other actions. That's when you use an explicit wait. Now, let's go and actually look at the code, see how explicit waits solve all the problems that implicit waits fail to solve. And then I'll also show you the problems that Selenium, a new version of Selenium, has caused us. So an explicit wait is code that you write to wait for some specific condition to happen before proceeding. One of the simplest ways to do an explicit wait is to use a thread.sleep. Thread, and then you of course need to import system.threading, and then you can do thread.sleep. And then you can set a time span if you want to do milliseconds. Let's say we want to do 1000 milliseconds, which is obviously 1 second. This right here is an explicit wait, because you're writing code that tells the system to wait for a specific condition, in this case to wait for 1 second. This is the worst kind of an explicit wait and it should actually never be used. Well, that's not true. It should only be used in situations whenever you actually need to wait. So for example, if you click a button and then some action is supposed to happen 30 seconds or 40 seconds after your button click, then you can use a thread.sleep. However, it should never be used to wait for an element to actually load. The other type of an explicit wait you can have is, again, another example of writing code is like this. For example, here we're navigating to this hidden element URL. Then we're using a WebDriverWait class that comes from Selenium namespace. Don't worry about this right now. We'll cover this more in detail. And using the WebDriverWait class, we write a link query that will wait until we find an element of this ID. So this will continuously poll the DOM to see if this condition becomes true. Let me show you exactly what I mean here. So I'm going to go ahead and debug this and show you exactly what's happening. This is another example of an explicit wait because it's code that we wrote to wait for a specific condition. In this case, whether the element is found. We could wait to see whether the element is displayed. We could wait to see whether the element is visible, whether there is text in an element or something like that. So here we have the two elements, the two pages side by side, and you know that on this page it's the hidden element URL, which means the element is there but it's hidden. And so now what we're going to do here is step over this action, step over, and you can see it'll throw an exception, no such element, but then it comes back and does it again. Every half a second, it will continue to poll to see if the element is there. And after our specified timeout that we set, which was 20 seconds, if it has not found that element, it will throw a WebDriver timeout exception, saying that timed out after 20 seconds because the element is not there. So that's code that I wrote telling Selenium WebDriver to wait for a specific condition on a specific element. Now, this way is good, but a little bit burdensome. Luckily for us, Selenium has created a very convenient way to perform these kind of operations, and that's called expected conditions. And I'm going to show you that to you next. Hey, so hopefully you're enjoying the course. Real quick, I wanted to give you a fantastic offer. As my current Ultimate QA student, I like to do these kinds of things for all of my students to encourage really good learning behavior. I like to throw in really good deals so that it encourages you to watch my courses. And randomly along the way, you might find a gold nugget that may or may not help you. If it doesn't help you, no big deal. But if it does, that's really cool, and I'm really happy about it. And as always, I just like to give away a lot of stuff on Ultimate QA just to create a better sense of community, to just also as a way to say thank you for, taking my courses and taking your time out of your day to watch all of the courses. So what I'm doing now is I've decided to just give away, for the first 100 students, my complete Selenium WebDriver course at a really huge discount of $99.99. Normally, this course goes for $350. You can see actually if I come over to this URL here, it's normally $359, $349. That's what everybody always pays. MSRP whenever they come. People pay $350. You can see everything that you can learn here. But again, for the first 100 students that are taking my courses, I want to give away this course for $100. And if you haven't heard of this course, the Complete Selenium course is the best rated course on the web. You can see some of the ratings here, but besides that, there are also a ton of testimonials that I've got all throughout here. You can read about this course and everything you're going to learn, but basically it will teach you how to create a complete Selenium WebDriver framework from A to Z. You're going to start by learning C#, and then it's going to go all the way until the end, until you have your own framework ready that's ready to report, has beautiful HTML reports, has logging, has page object model, and all that kind of stuff. So again, if you're interested, that's cool. All you have to do is go to this URL here, ultimateqa.com/current student offer. It will automatically redirect you to this page that's going to have a discounted coupon that will help you to buy the course for $800. And if you're not interested, no big deal. But if you are and you get to this page and you don't see that it says $100, that if it says $349 or even a higher price, because I always keep increasing the price of my courses, then sorry, you missed out and the deal is over, but maybe I'll do another one in the future, who knows. But if you didn't procrastinate and you did get to this page and you see this $100 offer, congratulations. I'm glad you got the offer. And hopefully you come in and get it real quick, because Ultimate QA gets about 50 students every single day. So I'm guessing this offer probably wouldn't last too long, but who knows? Maybe you'll get lucky and it'll last a little while. So anyways, I don't want to take too much of your time. Let's get you back to the course. Just wanted to give you a little present for making it this far in the course. Congratulations. Let's get back to the course. I know that I flew over this entire example of an explicit wait. And the reason I did that is because there is a more efficient and a better to read method of doing explicit waits. That's exactly what I'm going to show you next. It's the most convenient. And what I've done here to exemplify to you not only how these explicit waits fix the tests, but also they're more readable and they are easier to use. You can see I've placed the tests that were fixed implicitly over here on the left in the implicitwait.cs file, and then I have the same exact tests fixed explicitly over here on the right hand side in the explicitwait.cs file. So you can see that they do exactly the same thing. This one goes to a slow animation URL. Obviously, it's not going to have this step of setting an implicit wait because it's no longer required. It still fills out the credit card info and then it sets an explicit wait. I did the same thing for test 3, as you can see test 3 here, and then I did the same exact thing for test 4 as well. Okay? So you can see how they look side by side. They're the exact same code, but what's changed is one is an explicit wait implementation and the other is an implicit wait implementation. So let's dig in to the explicit waits so that you can better understand exactly what's happening. So here's the first test fixed explicitly. It's doing all the same actions as before, and down here is where we start to use an explicit wait condition. The way we use an explicit wait condition is you first have to initialize an instance of the WebDriverWait class. The WebDriverWait class comes from openqa.selenium.support.ui namespace. And you can see that there are two different types of implementations, two different types of constructors, and you can supply the different options. I basically have never used this constructor on line 25. However, if you find a need for it, let me know. I would be very interested to know why that would be needed. I've always used this first constructor. And so inside of this constructor, we've supplied a driver and a time span. The time span obviously lets us know how long we want to wait for an element before throwing a WebDriver timeout exception. That's what happens whenever we use our explicit waits. Also, just wanted to mention, make sure that if you're using the WebDriverWait class, you should have the appropriate namespaces imported up here. I wanted to show you those because I obviously coded previously, and so I imported all the appropriate namespaces. So back to here. So now that we have our wait class, which is going to do the waiting, the wait class has a method called .until. We can take a look at this method just using F12 to navigate to the definition. And you can see that it uses generics, and it basically allows you to create any kind of function that you want and wait for a specific condition to be returned. Let me better show you that. So in this case, what we can do is we can wait until an expected condition. An expected condition is something that Selenium has provided us to make life easy. So you can see that it comes from that namespace right there, openqa.selenium.support.ui.expectedConditions. These provide us many different options to check for the presence of an element. Take a look here. Here you can see the ExpectedConditions class living in the appropriate namespace. And these expected conditions are basically those explicit waits that we wrote for different kinds of possibilities. So you can see that we can wait for an expected condition such as alert is present, or an element exists, or an element is visible, or an element selection state to be a certain locator. We can look for invisibility of element located, and then you supply a locator. We can check for text to be present in an element, or we can check for that the title is something specific, or that a URL contains some specific fraction, or URL matches some regex. So you can see there are many different kinds of expected conditions, and that's why I said that this code right here is not too important, because in this case we were waiting for an element to exist, right? We were doing the find element, so we were waiting for an element to exist. However, that expected condition is already present for us, and so we can just use the expected conditions class to wait for that condition and save us a couple lines of code and just make our code more readable in that way. So in this case, for test 1 being fixed explicitly, we're waiting for an element to be clickable, right? If you remember the slow animation URL, that's the one where you fill out the forms. We're waiting for the purchase button, the go button, to be clickable before we click it. So here, that's what's going to happen is the expected conditions and the WebDriverWait will poll the DOM for 15 seconds for this condition to be true before trying to click. If it doesn't happen, the expected conditions class throws a WebDriver timeout exception if that's not possible. And then on the next step, we assert that it's true, and then again we use our wait.until expected conditions that an element is visible by ID, success, and that it's displayed. And so we're going to assert that this element is displayed. So we're going to wait for it to be visible for 15 seconds and then assert that it's displayed, whether it's true. So rather than talking, let me show you this test executing, and so then you'll be able to see everything going on. So I'm going to go ahead and run this test so that you can see it running in real time, right? Because as you know, creating a test on a developer environment and then running it in continuous integration are two totally separate things, because flakiness comes in your developer environment. I'm sorry, in your continuous integration environment. So you'll see that the purchase button was clicked and this test was passed successfully within 8 seconds. But however, did you see something weird? Let me go back to here and let's debug this test. Did you see something weird about this test? It seemed to run pretty fast, right? And even though the loading spinner was still loading, the test somehow still passed. Let's take a look at this again. Now we're going to put this on the side. There's the browser coming up. So we're going to wait until the go button, and then the go button is going to get clicked, And watch, this is still loading, but we're over here at this expected condition. And then when I step over it, it passes. Why does it pass? Well, because our success element is visible, right? At the point when I checked it, the purchase was visible, but the whole string purchase complete with the exclamation point was not loaded yet. However, this condition was true and the element was displayed, so technically it passed, but we still didn't finish for the element to be loading. So let me just finish up running the test so that it kills the browsers. Now that you're getting better familiarized with the WebDriverWait, the expected conditions, the understanding of explicit waits, let me show you some custom modifications, how to clean up your code and make it look a little bit better. And then, of course, I need to tell you about a huge announcement that came from Selenium that's going to change the way we do everything. So one thing that you can do now is I've created this test here, test for explicit wait rendered after. I'll show you exactly what it does. However, if you wanted to get rid of these expected conditions and to just have these methods present here, what you can do is actually, it's called a static import. So if I come up here and I uncomment this line of code, using static openqa.selenium.support.ui.expectedConditions, we now have removed the need to use expected conditions anywhere that we want. So now instead of doing that, I can do something like this. So obviously a preference. For me, it's a little bit more readable and obviously less code. So now it reads something like wait until element to be clickable or wait until element is visible. Something like that. So much more readable and again reduces code. It's just a preference, but if you would like, you have that option. The other things that I wanted to introduce you to were the different configuration options that are available on the wait. The wait, the WebDriverWait, which actually inherits from a default wait class. But the WebDriverWait, what you can do is you can set an ignore exception types method, and that will allow you to ignore different types of exceptions that might be encountered while the wait is performing its operation. So for example, you might be able to ignore a WebDriver timeout exception, or you might want to ignore a page, I'm not sure, invalid upper cast exception or some other exception that you don't want to be present whenever this is being evaluated. Keep in mind, however, you can't ignore the WebDriver timeout exception because that is the very basis of these methods right here. So you can't ignore this one, but you can ignore others. This is an okay method. I've had very few instances where I needed to use it, but you might find a need. I'm just making you aware. The other thing that you can do in order to customize your wait is you can add a message. The message is something that's going to be thrown whenever your WebDriverWait fails. So if you're unhappy with the WebDriver timeout exception message that says unable to find element, blah blah blah, waited for this amount of seconds, you can say, you know, something like well, here's the element that we're waiting for. Let me navigate to it real quick. I forget which, finish. Okay. So finish. So try to wait with ID finish, but the element wasn't clickable on the page after 5 seconds. So it's just something more customizable, something that's available. If you would like a more customized message, something that's more user-friendly. This is something I've used sometimes, you may find, just a preference whether you want a customized message for your failure or not, and you'll see how this message manifests itself whenever this actually fails. And okay, so with all of that coded and written, what I've done here is I actually finished up this test that goes to element rendered after URL. And so what it's going to do is attempt to wait for our element, right, which was with the ID finish. And that is not present because it's only rendered after we click a button in the HTML. So of course, this is going to wait for 5 seconds, and then it's going to throw a WebDriver timeout exception, which I catch, and then I proceed with the rest of the actions, which is waiting for, or trying, I click the button with the tag name button, and then I wait for that element again for 10 seconds this time. As you see, I've used another customization of the WebDriverWait in wait.timeout, and I reset it instead of the previous 5 seconds that we had set here before. I've customized it to be 10 seconds because I think that that is a better time to wait for that. And so let me place a breakpoint here, and I'm gonna run this test so you'll see exactly what's happening, and I'll better explain it as everything is going on. And of course, let me place the Visual Studio over here on the left, on the right actually. And then we'll wait for the browser to come up while the tests are spinning up. There it goes. See, the play button has started going. Now we've got our browser on the left hand side. And so now it's waiting for 5 seconds for that finish element to be found. However, the finish element is not found. And so a WebDriver timeout exception is thrown. And if we look at the immediate window, at the wait.message, this is the message that would be thrown with our WebDriver timeout exception. So you can see there's that message that we wrote. And so now we can step over this, and actually I'm going to let it run, and all it's going to do is click the button. You can see that now it started loading. We have no idea how long this might load for, but I've set a maximum amount of time of 10 seconds. And once it finished loading, it again checked for the element to be visible, which is the element that we were waiting for with the ID success. And in this case, the test has now finally passed. All fixed explicitly and now working. Because even though the element was rendered after the fact, we were now able to wait for it dynamically and find the element on the page. All right, so now that you know almost everything there is to know about explicit waits and implicit waits, I have an announcement to make that I've been trying to tell you, but I needed to teach you and show you everything first so that you can understand the impact of what has happened. I've actually written a blog post on this topic if you want to go to this URL and take a look in more detail. But basically, about less than 2 weeks ago, Selenium 3.11 was released. And in there, they've mentioned that 2 things are happening. One of them I'm not so much concerned about, but the other one I am very concerned about. One of the things that they're doing is they're removing the page factory from Selenium. Not a big deal because I don't teach you how to use it, and you shouldn't really need to use it because it's very flaky and hard to maintain. The other huge announcement that they've made is that they're saying goodbye to ExpectedConditions.cs. They're removing it from the WebDriver.net implementation. Yes, that's right. What I have just showed you with expected conditions will no longer be available in the Selenium WebDriver API whenever you download the NuGet package. Look, yes, it sucks and is very annoying. I talked to Jim Evans, and as you see, there's a link there. What he told me was that the reason that they're making these changes is because it's too hard to maintain the code in Selenium, and they want to reduce the complexity and maintenance of the code for Selenium. And even though expected conditions are extremely desired and highly used and very user-friendly for us, the developers of test automation, for whatever reason, they're removing it. I don't know if I agree with it. It doesn't make much sense to me to make something less user-friendly in order for code maintenance, but again, I don't maintain the Selenium code, so I can't speak to how much maintenance it is. Now, yes, it's very annoying. And what you're gonna have to do is, if you don't use expected conditions, you're gonna have to now start writing your own link queries like this. That's exactly why I showed you this. You're going to need to start writing your own these kinds of statements where you can find elements, where you can check elements for texts, where you can check to see if an element exists, whether it's visible, whether it's displayed, all that kind of stuff. But then another easier solution is that you can actually download a new special NuGet package. Selenium has been kind enough to extract the code into a different NuGet package, and we can actually use that one instead. So let me actually show you all of this. So let me pull up my Solution Explorer here, and I'm going to come here, right click, and go to Manage NuGet Packages for the solution. And as you can see, I've got some updates. I'm actually on, oh wow, I'm very outdated on my Selenium. As you can see, some places have 3.7, some have 3.4, others have 3.8. So what I'm going to do is actually update for you to version 3.11 on both of these. So I'm going to go ahead and click all of this. Oh, click all of that. C# doesn't need that. So I'm going to update all of these to 3.11, and I'm going to install it. Give that a second to update. I'm going to say okay, that yes, I want to update all of my NuGet packages to the latest version of Selenium. They're all being updated. And it's always a good idea to keep all your NuGet packages always on the latest software, and all of them to be the same across all projects. Just kind of a quick heads up while everything is downloading. Figure I'd give you as much tips as possible. So now that we've downloaded Selenium WebDriver NuGet package, let me go ahead and build and rebuild the code. And so now this is going to pull down all of the latest NuGet packages. And there's a problem here because you can see that I still have old NuGet package versions remaining here in my packages folder. So I'm going to go ahead and delete them. I figured that might happen, but I thought that NuGet package manager would have cleaned it up, but it didn't. So now let me go ahead and rebuild again. I was getting weird errors about mismatching namespaces in different versions. So now this is still complaining. So what I'm going to do here is right click here and go to Manage NuGet Packages. And then as you can see, I have some updates to install, and they are for Selenium support. So I'm going to go ahead and click this because these are currently version 3.7, but they can be upgraded to version 3.11, which is exactly the version that I just talked about. So I'm going to go ahead and click update so that it updates my NuGet packages in this project, WebDriver timeouts tutorial. So give that a second. It's added all the packages and successfully installed. Excellent. So now let's go back and look at our output. And if we look at the error list, what you now can see is this message. that expected conditions is obsolete. The expected conditions implementations in the .NET bindings is deprecated and will be removed in a future release. This portion of the code has been migrated to .NET Selenium Extras repository on the GitHub. So they are super nice to point us to where it has been migrated, but as they now say, this is now obsolete. You can use it for now, but in a future version, it's going to be gone and it's going to break your code. So you can prepare for that now, and I'm going to show you exactly how. So we'll even be able to see that in our explicit waits that you can see there's a green underline here that says, expected conditions is obsolete. So let's go ahead and fix that. And by looking at the error list, we can see that it says .NET Selenium Extras. So if we go into the Solution Explorer, come here, right click, do Manage NuGet Packages, and browse. And we're going to search for .NET Selenium Extras. So there it is, .NET Selenium Extras. We don't need the page objects, but we do need the wait helpers. So we're actually going to install it. Currently, as I'm talking to you, it's the end of March 2018. There is still no maintainer of this repository, but it does work. So I don't think it needs much changes. And so this version that I'm about to install, 3.11, will be just fine. So I'm installing it and it's downloaded. So now I can go back and now, instead of using support.ui, which we can no longer use, and so now, of course, this will complain, we can using OpenQA, Selenium Extras .wait helpers. So that fixed that, and then of course this needs Selenium support UI. There you go. So now everything, expected conditions, of course, is going to complain because it's ambiguous. And so what we have to do is set using static Selenium Extras .wait helpers. Expected conditions. And so now this is going to be great because the expected conditions, using expected conditions means that we're using these expected conditions, not the ones from here. So whenever the ones from support.ui disappear, our code is going to be great and ready, because if I hover over, you can see that we're using Selenium Extras .wait helpers .expected conditions. So now we are all good. So as I said, although it's a problem for future code because you're going to need to do exactly what I did to fix it, and just make sure that you use this NuGet package to fix all of your future problems. Sadly, I have no control over this. That's what the Selenium developers decided to do. So I just wanted to make sure that you're aware, because no one that I know has shown this or shown how to fix these problems yet. So I wanted to make sure that you're one of the first to know how to fix these problems so that you don't encounter them in the future. So now that we've covered everything there is to know about element synchronization, I wanted to teach you one final technique on how to appropriately navigate web pages and synchronize on them so that you don't run into flaky test automation, so that you drastically decrease it. I've actually never seen this technique taught anywhere else. So I wanted to bring it to you so that you actually know what to do and when. Everybody talks about how to synchronize, right, using implicit and explicit waits, but nobody actually defines a method for how to deal with different kind of flaky issues. And so I wanted to bring you a general approach that I normally follow. It's not foolproof. It's a general approach that will help guide you. In most instances, it will help to prevent flaky tests. And in some instances, it might require a little bit of improvisation. So we're going to do this with a quiz. However, I'm going to take you through all of the steps so that you know exactly what to do. And then you're going to need to code the quiz to make it work. So the general idea of how to properly synchronize using Selenium WebDriver is you want to open a page. Once you open up a page, you want to synchronize on the slowest loading element, and then afterwards you want to proceed with actions. What this means is every page load must be followed by a synchronization point using an expected or using an explicit wait on the slowest loading element. So if I was to do this, and this is what we're going to do for our quiz, what you're going to do is you're going to open up ultimateqa.com. Now, if we want to find the slowest loading element, what we can actually do is open up developer tools, as you saw I just did, and go to the network tab. I can refresh this page and I can see the network traffic, exactly how all of the elements come in. Over here on the right-hand side, you can see the waterfall chart. So it starts from the very first element, from the very first HTTP request, all the way to the very last HTTP request. You can see this is the one that occurs last. And even though here I actually see two other calls that you can see started and took quite a bit of time to load. So there's some PHP that was actually being executed. So if you want to find the slowest loading element, what you can do is scroll all the way to the bottom and see which element here was the slowest loading. You actually probably want to not look at any GIFs, any scripts, any style sheets. What you want to be looking for is an exact element, maybe some kind of like a PNG. Oh, here, perfect, a JPEG. So this is actually an image that was loaded. The reason we're not looking at anything else is because they're actually not elements, but they're part of the HTML, so it's kind of hard to sync on them. But for Selenium, since we're doing GUI-based stuff, we want to synchronize on an element. And so in this case, I found this one, which is a JPEG that we can synchronize on. So you can open it up and see what that looks like. But I can actually find it in our HTML by taking its name and then going to the elements and then using the Control F feature to find our string. And so in here you can see that I found this element. It's right here that lives inside of this div. And now I can use this div to synchronize on one of the slowest loading elements. It's not the last one, but it is one of the slower loading elements. And so now you can synchronize on it, and then the next step would be, once you synchronize on it, to click Automation Exercises link. So once you click the Automation Exercises link, the very next step is to, again, synchronize here, just exactly like I taught you. And then you're going to go to big page with many elements. And so now you're going to load this page. You're going to synchronize here and assert that this page is successfully loaded. I leave all of the implementation up to you, but you must have a solid running test that can run under any conditions. and obviously stable with no synchronization issues. So give that a shot. As I said, these steps will work the majority of the time. Be flexible. If you would like to synchronize on more than one element, you have that option, of course. Do your best, because a synchronization point is not necessarily bad. All it says is that the driver will wait for a maximum duration of time. So if the element that you're synchronizing on is already loaded, even though you synchronized on a previous element, it's not a big deal. You only lose about half a second, because that's how long the WebDriver will need to poll for that element. So give that a shot. Here's the test and its name. Code it out, and then when you come back, I'm going to give you the answer, and then this will be great practice for you to utilize all the skills that you've previously learned. If you're enjoying this tutorial and want to support this channel, be sure to hit the thumbs up button for the video. And if you want to be notified of every time a new tutorial is released, hit the subscribe button. Cool, so how did you do? Hopefully that wasn't so bad. I'm guessing you spent at least 20 minutes trying to figure this out. If you spent more, of course, not a problem. It wasn't an easy exercise, but it was a medium style exercise. But of course, you're learning new skills, so it may have taken you a little extra time. And if you went through it and actually got it working, that's fantastic. That's one of the most important skills to have, is to be able to persevere through failures, because they're very common with Selenium WebDriver, especially as we're learning and writing test automation. So here's my solution. Keep in mind that your implementation may have differed from mine. As long as your logical reasoning made sense and was similar to mine, you should be okay. The locators, all that kind of stuff, there's, obviously many different directions that we could have gone. I'll tell you why I made the decisions that you made, and if you think that your decisions were better, and that's cool, your implementation could be better. But if not, you can kind of use my logic to help guide you in the future. So standard, opening up ultimateqa.com, not a problem. Of course, we had to maximize the window, because if you didn't and you have a small size window, my browser, my website is responsive. So all the links disappear, and so you get this kind of style of navigation. So anything after that would make everything really hard. So you got to make sure that you maximize your browser. Then after that, I set a WebDriverWait, and then I already told you which element to sync on, and that was that image that I forget what it was called, but it was that image that was one of the last elements to load. So all I did was use its class name. That was a unique class on that page, and I synchronized to make sure that the element is visible, waiting for a maximum of 5 seconds. So once that element is visible, we can perform with the next action. For the next action, I chose to do another explicit wait. The reason I chose to do that was because I know that after that element loaded, there were several other elements that were loading. Let's show that again. The waterfall chart in the network. Let me refresh my page. So as you can see, there's a lot of stuff going on here. There's stuff going on here and stuff going on here as well that's taking extra time. And the element that we found, it was a JPEG, I believe. Give it a second. Oh, no, I'm way up here. Yeah, JPEG. So here, see banner. It's kind of like, there's many more elements after it that load. You can see here. So I wanted to keep it safe and just use another explicit wait. And so I use an explicit wait using by link text for the automation exercises, which are right there. So I was looking for an element found with link text. So, worst case, if it's already there, we just proceed. If not, it will wait for an extra 5 seconds, which is better than a flaky failure. Next, we went to the automation exercises page. Here, I looked at the waterfall chart, and then I was able to see that. Actually, it's funny because now the waterfall chart looks different than I saw it before. But I chose to synchronize on the header text, because actually when I analyzed it, the waterfall chart was pretty similar, where actually all of the elements were loading almost simultaneously. I wonder if it's because I had it cached. I'm not sure, but when I looked at it, almost all the elements were loading at the exact same time. So I just chose an obvious one, which was to use the header that contains the text, automation practice. And then once the header was loaded, and now seeing the waterfall chart again, it may have been a mistake. I might have wanted to synchronize on something else, and I'm actually looking for something else here. Maybe this Amazon PNG, or maybe, yeah, maybe that Amazon PNG could have been good. This one right here, let's see. Yeah, maybe this Amazon PNG could have been one of the better elements. So that was possibly could be improved on my end. But after I synchronized on that, I clicked the link with link text called big page with many elements. And then after that, I did a final synchronization, which was checking for this image called girl with laptop. So that was happening somewhere towards the bottom here. Let's keep looking. Trying to see it. Give me a. Oh, it's down here. All the way at the bottom, you can see girl with laptop JPEG. So there's girl looking at a laptop. So that was the element that I chose to synchronize on. Why? Because it's one of the last elements to load in our waterfall chart on our website. So using the title, I was obviously able to. Oh, sorry about that. I was able to go into elements, and then using Control F, I was able to search for girl dash with laptop. So here I have that element. You can see that this element actually has a title, which is great. And then I use the title, which is girl with laptop too. And so that was the title that I searched for. And then I just had an assertion that that element was displayed. And so that was the test with proper synchronization. If I run it for you, which is always the funnest part. Oh, I shouldn't have debugged it, but I should have ran it. But it doesn't matter. If I run it for you, you'll see that the test runs successfully. All the synchronization points have been placed well. And I believe that whatever environment this test runs in, it will not fail because all the synchronization points are in the appropriate conditions. So we can just take a look here. It's going to expand the browser. As you see, it's going to click the automation exercises. It's waiting for it to load, as you saw. Now it's waiting for this page to load as well. And then it closed because everything on the page is loaded. And we get a green check mark saying that our test has passed. So if you did it, congratulations. You've successfully mastered synchronization. Now just continue to apply these techniques to the rest of your automation tests.